Domain and range of tables and equations. So let's review. Domain describes all the possible independent values of a function or relation. So these are usually the x values, or if we don't use a variable, these are the inputs of an equation. Range describes all the possible dependent values, or these are the y's, or we call these the outputs. So let's talk about tables first. So when we have tables, all tables represent discrete data. We don't know if there's other values than what is given. Now, if the table is paired with an equation or a situation description, that may change. If all you're given is a mathematical table, then we must assume that it is discrete data, unless it's paired with an equation that says this is a function given by, and then it gives you an equation with x's and y's. So let's determine the domain of example 1. So for domain, those are our x's. Because this does not have a description or an equation attached to it, we assume this is discrete. So we're going to list out our x's because it is discrete, and by discrete we use a list. All of our x's. So our lowest x is -1. Then we have a 0, 1, 2, 3. So really all of these are the domain values, all the x's. With range, range is the y values. And again, we assume this is discrete, so we're going to list this from least to greatest. So we have the lowest of a 2, then a 4, then a 6, 8, 10. So all of our y column, or our y variables, that is what gives us range. They may not always be in least to greatest order. So if they're not in least to greatest order, make sure you put them in least to greatest order. So you guys try out example 2 and 3. See if you can get the domain and the range. What you should have had for your solutions for 2 and 3. Remember on 3, when you have a repeated value of a range or domain, we only need to list it once. And these were not in least to greatest order, so we had to make sure we reordered them for our solution. Now let's talk equations. So when you're using equations trying to find domain and range, you're basically using substitution. You're given one value, you're trying to find the pair. We like to think of equations as coordinate points, x and y. So if you're given the x's, you'll be given domain. If you're given y's, that means you're given range. Okay. Now, if I'm given domain, you're looking for the y's. If you're given range, you're looking for the x. You're looking for the other pair. And that's this last piece. If you are given domain, that means the x's. Substitute those numbers in for x, and to find the y value, find your range. On the other hand, if you're given range, that's your y's. Substitute those numbers into y to find the domain x. So let's look at example 4. It says, given that y equals 2x plus 4, if the domain is -1, 2, 4, find the range. So this is telling me that these numbers in this set are the domain. So since it's saying that these are domain, that means all of these are x's. Every single one of those. X equals all three of those numbers. What it's asking me to find is it says find the range. Well, I don't know what y's are equal to. That's what it's asking me to figure out. So we're going to substitute our x's into our equation one at a time to find the y value. So we have y equals 2 times. Now, the first x value is 1. That's our first one. So we're going to substitute that in. And then we still have plus 4 in our equation. And we're going to find the y. So 2 times -1, y equals -2 plus 4. Y equals 2. So here is our first range value. That's not your final answer because I have 2 more domain values. I still have 2 and 4. So now we're going to substitute into the same equation. We're going to substitute the next domain value. So in this case, a 2. Wherever you see an x, put a 2 now. And we're going to simplify to find the range. 2 times 2 makes 4 plus 4. So this range value is 8. And we're doing it one more time for the final domain value of 4. So 2 times the x is 4. And we're going to simplify to find y. So the range values, y equals 2 times 4 makes 8 plus 4, y of a 12. So the range in this problem, so for the range, I have 2, 8, and 12. Remember to list them in least to greatest. Use your domain to find the range. Now let's look at example 5. So example 5 is similar. It says given that 2x plus 4y equals 10, if the range is 4, 0, 4, 7, what is the domain? So this time I'm giving you range. Range is 0, 4, and 7. So that means all of these values are all y's because it says range. We are looking for the domain. So we don't know what the x's are. So we're going to substitute these values in for y. So first we're going to substitute y equals 0. So we have 2x plus 4 times y value of a 0 equals 10. Now this time I'm going to actually have to do some solving because x is not already by itself. So 4 times 0 makes 0. So it's just 2x equals 10 because 2x plus 0 is still a 2x. Divide both sides by 2, so x is equal to 5. This is our first domain value. Next, let's plug in the next y. So the next y is 4. So same thing, 2x plus 4 times, but y is now a 4, equals 10. And we're going to solve this guy for x. So 4 times 4 makes 16, so 2x plus 16 equals 10. Subtract the 16 from both sides. 2x equals negative 6. Divide out the 2. X is equal to negative 3. So there's a second domain value. And now we have to do it one more time for the third one. Y equals 7. So we'll plug in the y. So we have 2x plus 4 times the y value of 7 equals 10. And we're going to solve this guy for x. So 2x, 4 times 7 makes 28 equals 10. Subtract 28 from both sides. 2x equals negative 18. Divide by 2. X is equal to negative 9. So my domain for this one is now, we have negative 3. That's negative 9 is actually the lowest right here. Then negative 3 is the second lowest, and then 5 is the highest. So this would be my domain for this function given this certain range value. What if it's not discrete? So what if it's not a list? So in example 6, it says if the domain of 2x minus 5y equals 1 is negative 5 less than x less than or equal to 6, what is the range? So now notice it kind of split it apart. The domain is all of this. So kind of split it up. So these are domains, and I can also tell that they're domains because of this x here in the middle. Now it's asking me what is the range. So I'm looking for y's. This means I'm looking for y's. Now, before we took each individual number and substituted it in. Because this is not a list, the only two x values that I need to substitute in is negative 5 and 6. Just those boundary numbers. Those are the only two that I will need to substitute in. So let's talk about our equation. So we have 2x minus 5y equals 1. I'm going to first substitute in x equals 5. So we have 2 times 5 minus 5y equals 1. 2 times 5 makes 10. Subtract the 10 from both sides. We get negative 5y equals negative 9. Divide out the negative 5. And we end up with y equals positive 9 over 5. Now, That's a range value. We're going to hold on to that for a minute. The second thing I'm going to substitute is the other boundary point. So I'm going to substitute x equals 6. So we have 2 times 6 minus 5y equals 1. 2 times 6 makes 12. Subtract the 12 from both sides. Negative 5y equals negative 11. And then divide out the negative 5. So we get y equals positive 11 over 5. Now we have the two boundary points of our range. So first of all, which one is smaller? Not just because the negative 5 for the x was smaller doesn't mean its resulting y is also the smallest. In this case, that is true. 9/5 is smaller than 11/5. So the general layout for this is going to be 9/5, a y value, and then 11/5. Now, what symbols do we use? Look back at your original domain. For the negative 5, it was a less than. What that means is that would have been an open circle on that coordinate point. Well, if the x value was on an open circle, the corresponding y value for that is also an open circle. So this 9/5 has to be less than. Same kind of idea with the other boundary. This 6 had a less than or equal to, so that means that's a solid point. If this is a solid point for the 6, the x value, that means its corresponding y value of 11/5 is also a less than or equal to. This is your resulting range. 9/5 less than y, less than or equal to 11/5. Let's try our final one. If the range of y equals negative 2x plus 1 is negative 19 less than or equal to y less than negative 3, what is the domain? So again, it kind of split it apart. The range is negative 19 less than or equal to y less than or negative 3. So range is all of this stuff. And again, we can tell because there's a y here as well. It asks me for what is the domain. So that means I'm looking for my x's. Just like number 6, all we need to do is substitute y equals negative 19, and we need to substitute y equals negative 3. Those are the only two we need to substitute. So first one, y equals negative 19. We're going to plug that one in first and solve this for x. So negative 19 equals negative 2x plus 1, and we're going to solve this guy for x. So we get negative 20 equals negative 2x. Divide by negative 2, x equals 10. Hold on to that domain value. Now we need the other boundary point. So we're substituting y equals negative 3 and solving for x. Negative 3 equals negative 2x plus 1. Subtract 1 from both sides. Divide out the negative 2. And we get x is equal to 2. So we need to put this into least to greatest. So our domain, our smallest value is actually the 2. Then we'll have x. Then our large value is the 10. Now we need to figure out our symbols. It's either less than or equal to. So let's take a look at our original range. So on the y value, the negative 19 had a less than or equal to. So that means its corresponding x value also has to have less than or equal to. So when we plugged in negative 19, it resulted in a 10. So that means the 10 has a less than or equal to. Similarly, the negative 3 y value has a less than, so its corresponding x value also needs a less than. So we plugged in negative 3 here, and that gave us a value of 2. So the 2 needs to have a less than. And there's the resulting range from a domain of negative 19 less than or equal to y less than negative 3.